In section 4.2, we're going to study the concept of irrational numbers. Now let's take a look at the different numbers in these two boxes here. The numbers on the left are called rational numbers, and the numbers on the right are not rational numbers. How are radicals that are rational numbers different from the radicals that are not rational numbers? Well, if you go to your calculator, try to evaluate all of these numbers or all of these radicals using your calculator, and you realize that the square root of 100 is 10, the square root of 0.25 is 0.05, the cube root of 8 is 2, the square root of 9 over 64 would be 3 over 8, and the fifth root of negative 32 would be equal to negative 2. If you were to square 0.8, that would be 0.64, okay? And these are all rational numbers. Now, if we take a look at the square root of 24, the square root of 0.24, sorry, that's equal to 0.48987, etc. The cube root of 9 is 2.0800838, etc., etc. Root 2 is 1.414213, etc., etc. And hopefully you can start seeing that these numbers in this box, they are decimals that go on forever, and they are non-ending, non-repeating decimals. So the box on the right has non-repeating non-terminating, meaning it never ends, decimals. And it cannot, these numbers on the right cannot be written in the form a over b like rational numbers. So these are called irrational numbers. Now, unlike powers, with roots we don't always get rational numbers. And we said that rational numbers can be written in the form as a over b, and irrational numbers cannot be written in the form a over b. The decimal values of irrational numbers neither terminates nor repeats, and that's exactly what we said on the previous slide. Okay, so taking a look at this rest of the exploration, which of the following radicals are rational numbers, which are not? Okay, well, this one right here would be irrational because there's no exact value for the square root of 5. The square root of 4 over 5 would also be irrational because you could write that as root 4 over root 5, and the numerator is 2, but root 5 is not a rational number, or an integer, sorry, so it would not be considered a rational number. The rest of these would all be considered rational. Okay, and for parts 3, write 3 other radicals that are rational numbers. Okay, so again, you could have the square root of 25, you could have the square root of 1/4, you could have the square root of 49. Those would all be considered rational. And 3 other radicals that aren't rationals, well, root 6, root 7, root 10, those would all be irrational numbers. Okay, again, taking a look at these, which is irrational, which are rational, this would be considered rational. This here, the cube root of 8 is 2, the cube root of 27 is 3, so it can be written as a ratio of 2 integers. So this would be irrational, or this would be rational, and B would be irrational because there's no perfect square of 14. All right, taking a look at these, which of these are rational and irrational? Well, the square root of 49 over 16 is really 7 over 4, which is rational. The cube root of negative 30 is not a perfect cube, so this would be irrational. And 1.21 is a decimal that ends, so this would be considered rational. Okay, so back in elementary school, you were taught about the natural numbers, and the natural numbers are your counting numbers. And then the natural numbers, the next whole number system was the whole numbers, and the only difference between the natural numbers and the whole numbers is the whole numbers included 0. And then we had integers, and integers were positive and negative numbers, including 0. And rationals were as we talked about, any ratio of two integers where the denominator is not 0. Now, irrational, we said we're going to be all numbers that are on the number line that aren't rational, okay? And basically, real numbers are any numbers that go on the number line. So any number that fits on the number line, whether it be a decimal, a terminating decimal, a non-terminating decimal, those are the real numbers, okay? So that is the real number system. Okay, let's look at the following statements and see which are true. All natural numbers are integers. Well, natural numbers fall into the category of rationals, and they also fall into the category of integers. So yes, that's a true statement. All integers are rational numbers. Yes, because all integers can be written over 1. All whole numbers are natural numbers. No, that's a false statement because 0 belongs to the group of whole numbers and not to the natural numbers. All irrational numbers are roots. All real rational numbers are roots. All irrational numbers can be written as, well, no, because we also have pi, which is not a root, so that's a false statement. Some rational numbers are natural numbers. That's a true statement, yes. Okay, so those are the 5 questions dealing with the real number system, natural numbers, whole numbers, etc. Okay, last question here. We want to use a number line in order to order these from the least to greatest. Okay, so let's use some of our deductive reasoning skills. We only have one value that's going to be negative, and that's going to be the cube root of -5. So that's going to be the smallest one. Okay, now we know that the square root of 9 is equal to 3. I know the fourth root of 27 has to be less than 3 because the cube root of 27 is 3, so the fourth root would have to be less. We know that the square root of 18 is going to be greater than 4 because the square root of 16 is 4, so this is going to be greater than 4. And the cube root of 13, we know that that's going to be less than 3. Okay. So if we order these, okay, we're going to have, well, the largest one is going to be root 18. The next one would be 9. Oh, sorry, 3. That'd be the cube root of 9, which is 3. And then we're going to have the cube root of 13. And the second smallest would be the fourth root of 27. So you can check those on your calculator to verify, but those would be the order of those numbers from smallest to largest. Okay, there's your assignment for section 4.2 on irrational numbers. Give those a try, and again, check the website for the answers.